Imagine being able to step into your own designs, walk through your creations, or collaborate with colleagues across the globe, all before a single screw has been turned or a brick has been laid. That's the game-changing power of spatial computing, and it's turning traditional engineering on its head. But here's where it gets really interesting. Not everyone agrees on just how soon this technology will reshape the entire industry, or whether the investment is justified for every use case. Today, augmented reality, AR, virtual reality, VR, and mixed reality, MR, are rapidly evolving from futuristic gadgets to practical engineering tools. These technologies are increasingly relied on for everything from detailed visualization, seamless collaboration, jaw-dropping presentations, and beyond. Chances are you already have a device in your pocket, a smartphone or tablet that can deliver AR experiences. But to immerse yourself fully in VR, you'll need a specialized VR headset. And here's the part most people miss. There's now a wide selection of headsets on the market, ranging from affordable consumer-grade models to ultra-high-performance enterprise headsets. Some advanced models are self-contained, operating independently with built-in processors. Others rely on a powerful external computer or engineering workstation, particularly for demanding tasks that require high-resolution visuals. But the hardware is only half the story. The software ecosystem supporting spatial computing grows stronger by the day. Many leading CAD, computer-aided design programs, now feature direct support for VR, allowing designers to jump into a virtual version of their models with a simple click. There are even collaborative review platforms that offer markup and team-based feedback within the VR environment. Game engines or real-time 3D tools make it possible to turn CAD files into fully interactive AR and VR scenarios, expanding what's possible for custom engineering solutions. If you're worried about the price tag, you're not alone. Spatial computing asks for an upfront investment, not only in equipment and software, but in time to master new tools. Yet for many in engineering, architecture, and manufacturing, the returns are proving to be more than worth it. VR delivers a level of intuitive understanding and rapid design iteration that standard 2D screens can't touch. It's quickly becoming indispensable in modern engineering workflows. Let's take a closer look at how various disciplines are tapping the unique strengths of spatial computing. Visualization and collaboration. With a mixed reality headset or a smartphone enabled for AR, visualizing in scale is nothing short of transformative. While a small bracket might be easy to grasp on a screen, trying to conceptualize something as massive as an airplane or a factory floor is much more challenging. Spatial computing lets you view these large, complex models at their true size, making it infinitely easier to spot mistakes, misfits, or design opportunities. This real-scale visualization shines brightest for those who design spaces, like architects. VR enables a virtual walkthrough of an unbuilt building, giving you a feel for the proportions, lighting, and flow that static renders can't replicate. Want to switch up the materials, change the lighting, or preview the building during different times of day? In a virtual environment, you have total freedom to experiment with your design in real time. Spatial computing isn't just about solo exploration either. One of its standout advantages is the ability to host multi-user sessions where global teams meet as avatars, collaboratively reviewing and discussing models as if examining a physical prototype in the same room. This not only saves on travel and physical prototyping costs, but accelerates decision-making and often leads to better engineered results. Factory planning, maintenance, and optimization. The benefits of spatial computing travel far beyond the drafting board. In manufacturing, VR and AR are revolutionizing plant layout, factory planning, and even day-to-day operations. Like architects, factory planners can virtually walk through facility layouts, identifying inefficiencies or hazards, such as equipment collisions or tight workspaces, long before any machinery is installed. Perhaps even more crucial is the ability to simulate worker interactions. Ergonomics can be tricky to perfect, but using VR, it becomes much clearer where a process might force someone to make awkward or repeated movements. Early identification of these issues means they can be fixed before expensive changes become necessary. Let's not overlook equipment upkeep. Imagine a technician guiding a worker through AR, highlighting problem areas on a tablet screen as they talk, or training on complex machinery with a hands-on VR manual, building familiarity without ever touching the real equipment. Operators can also benefit from VR simulations to practice routine tasks and prepare for emergencies like fires or chemical spills. Isn't it safer and smarter to make your mistakes in a simulated world? Presentations and marketing immersive spatial computing experiences aren't just for internal teams. They're a powerful tool for sharing ideas with clients and customers. Internal presentations benefit from showing products in their full, realistic context, making design proposals far more convincing than traditional drawings or slides. On the consumer front, expectations are evolving fast. Shoppers want to see how a new couch looks in their living room, or how a paint color fits in their kitchen, all from the comfort of home. Spatial computing enables this, offering interactive previews and customization in real time. This not only helps consumers make confident choices, but gives brands a compelling, personalized edge in a crowded marketplace. But here's the twist. Some critics argue that the hype may have outpaced the reality, at least for now. Are the upfront costs and learning curves worth it for every engineer, architect, or factory? Where do you see the biggest potential, and where do you think it's still more hype than help? Share your perspective. Do you see spatial computing as a revolution, or just another passing trend? Join the conversation and let us know in the comments below.